Hello friends, in the last lecture we have solved the problems of equilibrium considering the surfaces are perfectly smooth. Now in this lecture we are going to discuss when the surface is rough, that when it will offer some frictional resistance, then considering equilibrium, how to solve such problems in equilibrium, that we are going to discuss in this particular lecture. So what is a friction? When two surfaces are in contact, the tangential forces which resist the motion of a body, this force which opposes the motion, that is called as a frictional force. For example, if you take this is one surface and this is other surface, when one will move or other like this, the force which is tangential to this surface, it will oppose the motion. This is called as a frictional force. What are the types of friction? Dry friction. When two bodies which are in contact along a dry, non-lubricated surface, that is called as a dry friction. When layers of a fluid, they are moving with different velocities in different directions, that is called as a fluid friction. Okay, so this in general you should know. Now let us take this is a surface horizontal, and on this particular object, solid object is resting. When I apply a force P, now then in this case this horizontal surface is a rough surface. So you know, for rough surface how the reactions are generated at the point of contact through the CG. This normal reaction will generate, and this W is a sulfate of this surface. And frictional force, you see, the P will try to move this body on horizontal plane to the right, and that's why the frictional force will act in the opposite direction. Now when this P is less than the frictional force offered by the surface, then there will be no motion. In that case we can take coefficient of friction, as you studied in 11th and 12th, that is called as a static friction, coefficient of static friction. When P is exactly F, it is called as a impending motion. Impending motion means what? When P will become to F, the block will be just on the verge to move, but it has not started its motion. That is called as an impending motion. Further increase in the load causes the motion. In that case also mu, you can take it mu s. But when P becomes greater than F, whatever the frictional force offered by the surface, it will be less than the total force applied. In that case the body will be in motion, and coefficient of friction will have to take coefficient of dynamic friction, kinetic friction, that is mu k, where mu s and mu k are coefficient of static and kinetic friction. F is a frictional force. Remember, F is always, this F is always mu times this normal reaction, that you should not forget. Okay, now what is angle of friction? To replace this F and N by single force, inclination of R with respect to the vertical axis, with respect to this vertical axis, is given by tan this phi s, that is F by N. We know F equals to mu N, so N will cancel, and tan phi s is mu s. So in static, if you consider coefficient of static friction, then tan phi s. And if you consider kinetic, coefficient of kinetic friction, then you should take tan phi k. So these are the simple terms which you must learn. Angle of repose, the value of angle of inclination corresponding to the impending motion is called as the angle of repose. Now when this theta, angle made by this inclined surface theta, is a less than angle of repose, no motion. When theta is equals to the angle of repose, that is called as a impending motion. And when phi is greater than phi s, then there will be motion. Angle of repose, I will explain you in simple term. A particular matter like food grain, you just pour it on the surface, on a plane of paper or on a top of table, you will find there will be, the heap will be formed by the food grains like this. So this inclined surface, angle made by this inclined surface of the food grains with the horizontal, that is called as a angle of repose. And if this angle of repose actual angle theta inclination. If it is less than 5 years, no motion. If phi is equals to 5 years, impending motion. If phi is greater than 5 years, then there will be a motion. Okay, these are the forces on inclined surface. You see, this P is applied force, W is the self-weight of that block. This is the normal reaction. This inclined surface perpendicular to this is a normal reaction. Okay, and this is a frictional force. When the block moves up, frictional force will move down, but it will be parallel to the inclined surface. This you should understand. Okay, then let us take a very simple numerical on this block friction. You see, this block is resting on inclined plane and a force of 100 Newton is applied. This inclination is given. This horizontal is 3, vertical is 4. So you can find out this angle theta, tan inverse 4 by 3, and it comes to 53.13 degrees. So a 100 Newton force act as shown on a block 300 Newton. Self-weight of the block is given 300 Newton placed on inclined plane. The coefficient of static friction between the block and the plane is mu s is 0.25 and kinetic friction is 0.2. Coefficient of kinetic friction is 0.2. Determine whether the block is in equilibrium and find the value of frictional force. So for this, see, when the block is resting on inclined plane, the inclined plane you assume it as a x-axis like this, and perpendicular to the inclined plane that you assume it as a y-axis. Okay, next is, you see, this force 100 Newton which we have applied to the block is parallel to the surface. When block moves up, frictional force will oppose the motion. It will acting downwards parallel to the incline, and this 300 Newton force I will resolve into two components. You see, this angle is theta, then the angle made by this 300 Newton with its normal is also theta. If you want, you can draw it on paper and check. Okay, now this 300 Newton, if I resolve, the component along normal like this will be 300 cos 53.13 Newton, and component of this 300 Newton parallel to the inclined plane, this component will be 300 sin 53.13. Now why this component is sin? Because angle with respect to normal is theta, and that's why this component I have taken cos and this component is sin. Force is acting downwards, that's why this component will be acting downwards and this will be acting like this. Okay, so I have resolved the forces now parallel to the inclined plane and perpendicular to the inclined plane. Now if I take summation of y, so what will be? N minus 300 cos 53.13. So you see, summation of Fy will be equals to N minus 300 cos 53.13 equal to 0, and that's why N equal to 300 cos 53.13, and hence N equals to 180 Newton. So we got normal reaction. Now summation of Fx. Fx means what? Forces along inclined plane. So along inclined plane, what are the forces acting? This 100 Newton, if you refer the previous figure, 100 Newton acting upwards, that's why it is positive. F is acting downwards to the inclined plane, that's why negative. And this 300 sin 53.13 also acting downwards, that's why negative, equal to 0. Okay, so here F we know mu times N. So F is, if you substitute the static friction 0.25, you will get F required. F is required. This F is a required frictional force to maintain the equilibrium of the block. It's, we are getting minus 140. You see, this we are getting minus 140. So previously, what was our assumption? Under the action of this 100 Newton force, it is moving upwards, but this is not the case. When we got F minus, it means even though you apply this force, the block is moving downwards. That is the meaning of minus. Now the force required to maintain the equilibrium is 140, directed toward the right, means upwards. Okay, what is the maximum value of frictional force generated? Normal reaction is 180 and static friction is 0.25, 45, but required is 140. Since the value of the force required to maintain the equilibrium is 140 is larger than maximum value of friction, that is 45, equilibrium will not be maintained and the block will slide down the plane. Actual value of frictional force when it moves down, mu k into n, 0.2 into 180. When the block will move down, this is the only frictional force generated, that is 36 Newton, whereas the required value of frictional force is 140 Newton, and that's why the final conclusion of this problem is equilibrium will not be maintained. What is asked? Determine whether the block is in equilibrium and find the value of frictional force. So we have determined in both the cases, static friction 45, dynamic friction 636, but the required value is 140, and that's why the equilibrium is not maintained. So this way we'll have to comment on this problem. So in the next class we'll discuss some more examples on this blocks which are resting on the inclined plane. Thank you very much.